for another exciting class?
Yes. Oh my god. It's so nice outside.
I know why. I hate this class.
So boring.
Yeah, no kidding.
What are we learning about today?
Hi class, today I'm going to be teaching you about 6 different types of chemical reactions. They are double replacement, synthesis, acid-base, combustion, and decomposition and redox. But we're only going to be learning about 3 today, so I've went ahead and written 3 on the board. There are redox, combustion, and double replacement, so can you tell me which one is which?
I have no idea.
Yeah, I know.
Why do we have to learn this?
Yeah, it seems like we just don't need to know this at all.
Well, you definitely need to know it because reactions run the world.
What runs the world? Reactions. 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 Kids don't even try to touch this. Well, this is combustion. Fuel, heat, and water. Your car is driving, baby. This goes out to hydrocarbons reacting together to break the bonds, forming explosive reactions, all with oxygen.
Okay, so then the second reaction is the combustion reaction?
Yeah, it's composed of hydrocarbons, which are composed of carbon and hydrogen, react with oxygen gas to form carbon dioxide, water, and energy.
Exactly, but this reaction doesn't occur normally because you have to add heat for the bonds to break and release energy.
Okay, so then to limit the reaction, you would have to limit the fuel source, which is the hydrocarbons, or the oxygen, or the heat added that makes it, makes the bonds break.
So like when you're burning a candle, if you put it out, you can put it out by covering it up, but you stop the flow of oxygen.
Right. So combustion is especially important in any kind of engine, so like cars, jets, and maybe even spaceships wouldn't work.
Okay, so then you'd be walking everywhere like that kid.
That would suck.
Okay class, settle down. Now into double replacement reactions.
I think I need a double, or maybe a single. I will displace you, I switch up with an element, forming another compound, something else new, my reaction maker, precipitate.
Okay, so reaction 1 is a double replacement reaction because it involves 2 compounds which switch places.
Right, so in this reaction, the silver and the sodium switch places, which forms the 2 new compounds. But sometimes the new compounds aren't soluble, right, so they form a precipitate.
But how do you know if a precipitate will form?
Well, if you look at your handy-dandy solubility chart that I gave you earlier, you can see whether or not a compound will be soluble. So normally nitrate compounds are soluble, so in this case sodium nitrate is aqueous. And normally bromine compounds are aqueous, but in this case when it's paired with silver, it's not, so it is insoluble and forms a precipitate. Do you guys understand this?
Yeah, I think that makes sense.
Yeah, it makes a lot more sense now.
Redox, you know you love it. How we're giving and taking these electrons. Biological reactions, synthesis and respiration. See, this is what I can do. Control many processes. Yeah, you really need me. Respect me.
Okay class, so we're going to talk about redox reactions. These are pretty difficult to understand, but just remember they involve the transfer of electrons. So oxidation is losing electrons and reduction is gain of electrons.
Okay, yeah, I remember my friend took this class last semester and she said a really cool way to remember it was oil rig, I think. It's oxidation is loss and reduction is gained.
Yep, that's a great way to remember it. So in this example, can you tell me which one is oxidized and which one's reduced?
Yeah, so like magnesium starts from an oxidation of 0 to 2+, so it's oxidized because it loses electrons. And then nitrogen is reduced because it starts from 0 to 3-, so it's gaining electrons.
So the confusing thing you have to remember is that the element that is reduced is actually the oxidizing agent, and the one that is oxidized is actually the reducing agent, like magnesium in this case.
I can see how I would probably mix that up on the test, but I think I understand it now.
All these atoms think they single like we are, but no they're not. Mix them up, creations form, dissociate, precipitate.
Wow, I can't believe I actually paid attention in class today. I might have even learned
I
something.
don't know, I can't believe reactions do run the world.
Okay class, well that's all I have for today, so I'll see you tomorrow.